All right, let's go ahead and look at the warm-up. It says identify the polygon by the number of sides and determine whether it's equilateral, equal angular, regular, or irregular. So based on the number of sides, what can we classify it as? What do y'all think? How many sides does it have? 5. So what's a 5-sided shape called? A pentagon. And then do y'all think it's equilateral, equal angular, regular, or irregular? This one would be your irregular. It's none of them. None of them being it's not regular, equilateral, or equiangular. All right, so let's go ahead and look at the notes today. We're going to get into chapter 6. So yesterday was the introduction. Today we'll get into chapter 6. We are going to be looking at quadrilaterals. So all the 4-sided shapes, or actually today we'll be looking just at polygons. Tomorrow we'll be starting the quadrilaterals sections. Trying to remember the word. All right, so we looked at diagonals already. We saw the word diagonal, or I introduced the word diagonal when we did the 45, 45, 90 triangle. And we drew a diagonal to make a square into 2 isosceles right triangles. A diagonal has to be drawn from one vertex to an opposite vertex as long as it's not next to it. So it can't be a side, in other words. So we can draw a diagonal going to R, going to S. We cannot draw it to Q because that's a side. We cannot draw it to T because that's a side. What type of shapes did I make in here? Triangles. How many degrees are in triangles? 180. Good. So it says draw convex polygons with 3, 4, 5, and 6 sides. So it doesn't have to be perfect. Just draw polygons that have 3, 4, 5, and 6 sides. Just make sure they're convex, so none of the sides can go in. So 3-sided shape, a 4-sided shape, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So they don't need to be pretty. Just kind of sketch them through. All right, and then when you're done, though, we're going to start drawing diagonals. So let me wait a minute to make sure everyone has them drawn. From one diagonal, from one vertex, we're going to draw a diagonal. So if I was to make a point here at this vertex, can I draw a diagonal to either corner? No, because I'd be overlapping the sides. How about from this corner? Can I draw a diagonal? How many? Just one. You can only draw it here. From this corner, and I'm just picking a random corner. It could be any vertex, how many diagonals do you think we can draw from this one? 2. You'd go opposite here, opposite here. We cannot go to the right, and we cannot go to the left or to the top because those are sides. All right, we'll pick another one on the last one. How many do you think are going to draw on the last one? 3. What was the pattern there? We went from 0 to what?
1.
To then 2, and then 2. 3, right? We just started adding 1. So we're going to fill out this little chart based off of these drawings. A triangle has 3 sides. There was only one triangle in it. And one triangle times 180 is just 180. All right, so the second one, a quadrilateral, had how many sides? 4. How many triangles were in this one? 2. What's 2 times 180? 360. Good. All right, let's do the next one. How many triangles do we have in the next one? 3. 1, 2, 3. Number of sides. This one had 5. 3. What would be 3 times 180? 540. Good. The hexagon has 6 sides. How many triangles were in the hexagon? 4. And then 4 times 180 is 720. If you look at the title of that column, this is the measure of the interior angles of that specific shape. That means every pentagon is going to be 540. Every hexagon will be 720. Quadrilateral, this is the main one. We're going to be using this one a lot, is 360. So you know how I had y'all memorize triangles is 180, at least for those of us that didn't know that already. Y'all need to memorize the 360. Every 4-sided shape is 360. Okay, do y'all notice the pattern? Look at the columns. Go from the first column to the second column to the third column. What's the pattern here? What now? Both of the numbers go up by 1. Good. What else? Each time we're adding the 180. So we do have to multiply by 180. So I'm going to add that there. We have to multiply by 180. What else do we have to do? How am I getting from that first column to that second column? Do you notice the pattern from the first one to the second one? You take away 2. So however many sides we have, whatever the number is, we're just subtracting 2 from there. This right here is your formula. That's what we're going to notice. So our formula is going to be the number of sides, so whatever number we had, minus 2, and whatever that outcome was, we multiplied it by 180. That is the sum of interior angles formula. So that's what we're going to write right here in that box. So in that box, we're going to write n minus 2, that's the formula, times 180. And what did the n represent? N represents the number of sides. Good job. The number of sides. So if you look at the shape on the right side, we have 1, 2, 3, 4, 5. There are 5 sides. And here we have 5 minus 2, because it's 5 sides minus 2, times 180. And we said that was 540. Okay? So before, when we were solving triangles, we always knew the total was 180. So the case with today is you're going to have to figure out what the total is, because if you're going from a hexagon to a decagon, their totals are going to be different. So that's going to always be your initial step. So for the first example, it says find the sum of the measures of the interior angles of a nonagon. If you had a guess, how many sides does a nonagon have? 9. Good. So nonagon means 9, so you have to know what the vocabulary word is. And then you just write out the formula, and we plug in. So 9 minus 2, 7, and then 7 times 180. What would that total be? 1,260 degrees. That's it. So if you look at part B, this formula is going to be our initial step. Because it says here's a 4-sided shape. And again, we're going to have 4 sides memorized. Okay? But let's say we don't know. It says find the value of x in the diagram shown. Well, then your first step, because you're going to have one that has a different amount of sides, your first step would be to do 4 minus 2 times 180, and we get that to be 360, right? Because eventually we'll have that memorized. That just means the total, all of them have to add up to what? 360. And if you want to write everything out, you can. If you already know you're going to combine these two, we can add those two. But we'll write it all out just so everyone has the whole formula there. All right, combining like terms, what would be 120 and 48? 168, good. What about 2x and 3x? 2x and 1x? 3x. All right, let's go ahead and solve for x. Let me know what you get for x there. 56. And that's all it wanted. It just wanted the value of x. So on the next page, I'm going to have you guys try one of each, okay? So I'm going to leave this up so you have it. Was that right? Did you get something different? Was it 56? Well, what was it? 64? Okay, just correct me. 64. Sorry, I thought I heard 56. All right, so I'm going to leave this up so you see the examples. That way you're not going back and forth. But let's go ahead and try the practice. All right, let's check what we have. So this one is an octagon. An octagon has how many sides? 8, good. So this one should have been 8 minus 2 times 180. What did y'all get for that total? 1,080. Mm-hmm. All right, did everyone get 1,080 on that one? All right, next one. First step should be to do what? What should we do first? What do y'all think? The formula, good. So how many sides do we have? 5, good. So 5 minus 2 times 180 would give me a total of what? 540. What are all your angles inside? What do we have inside the shape? Just tell me the angles is what I'm asking. What angles do we have inside? 113. What else? 4x. 3x plus 8. 2x plus 9. And there's one more. The 113. Reminder that if they're marked congruent, they are identical. And this should equal 540. All right, combining like terms. What did y'all get for the whole numbers here. What would be 113, 113, 8, and 9? What was that? 233. What about the x's? 43. What about the x's? Wait, 43. 243. There we go. What about the x's? 9. All right, so did we all get up to here? We all get these numbers? All right, so then what was the value of x here? Because from here we should all get this. 33? Did we all get 33? Yes, okay. All right, value of x. All right, so first step was to find the total, because without the total, you won't know what to set it equal to. And then be careful with the diagram. That one did have one missing, but because it was marked identical, we did know what that angle should have been. All right, so here's a different type of question, though. Still looking at the formula, though. It says, if a regular convex polygon has an interior sum of 1,800, what is a polygon? So what are they giving you here? The sum. They're already giving you the total. So their question is, how many sides does it have? So we take our equation, and what do we do with it? If that's the total, where do I want to put it at? On the other side, right? So this equals 1,800. Look at the process. It's n minus 2 times 180. You're undoing the formula. What's the last thing we have to do in the formula? N minus 2 times 180. What's the last thing we do here? Multiply. So what's the opposite of multiplying? Dividing. Good. What are we going to divide by? 180. Good. So divide by 180. What do we get when we divide by 180? 10. And then what do we have to do with the 2? Add 2. Good. So n equals 12. Now we do know what 12-sided shape. What's the 12-sided shape called? A dodecagon. If it's anything past 12, you would just put a 13 gon, 15 gon, 20 gon. But up to the 12, we should have a name. All right, go ahead and try the next one. All right, we take n minus 2 times 180. We should set that equal to 2340. What should be the first step? Divide. What do we get after we divide? Everyone agree it's 13? Yes? All right. What should we do next? Add the 2. Do we have a name for a 15-sided shape? No. Mm-mm. So then this would be called a 15-gon because it does ask you to classify it. All right. All right, same formula. Let's see what we have to do with it now. It says the poles of a tint form the vertices of a regular hexagon. When the poles are properly positioned, what is the measurement of the angle formed at a corner of the tint? All right, what keywords do we have here? Hexagon, what else? Regular. What does regular mean?
That they equal angles and sides.
All sides and angles are congruent, right? So we can just say angles and sides are congruent. Angles and sides are congruent. And how many sides does a hexagon have? 6. So do they want to know the total? If the question is, what is the measure of the angle formed at a corner? How many do they want to know? Just one angle. Just one angle. So what should we do? Should we figure out the total first? Yeah? Okay, figure out the total first. All right, so 6 sides. 6 minus 2 times 180. What does that get us? 720? Bless you. How many, what should we do with this, though, if we're just trying to look for one? We got to divide, but do y'all know what we're going to divide by yet? 6. How many sides does a triangle have?
6.
How many sides does a triangle have? 3. How many angles does it have? All right, think of a quadrilateral, any one, a square or rectangle. How many sides does that have? How many angles? 4. It's always going to be the same number. So because it's a hexagon, we should take the 720 and divide it by 6. Good. So what's 720 divided by 6? 120 would be one interior angle. All right, so let's look at what we did. We used the formula. What was the formula that we used first?
N-2.
Times 180. And if I wanted to find the measurement of the angle, what would we have to do with that number? What did we do after we found the total?
Divided by N.
Divided by n. So I would just leave it as dividing by n, not the a. I know it says a for angle. Because the n is going to be the same number, right? It was 6 minus 2. We also divided by 6. The n's here should always be the same number. Okay? All right. I'm going to have you guys try one. You're looking at a food court there. So see if you guys can do the food court problem. All right. So this one's just looking for one. It says find the measurement of one interior angle. Alejandra, what did you get here?
108.
108. Did everybody get 108? Yeah. Okay. All right, let's look at 6. 6 says, the measure of an interior angle of a regular polygon is 135. Find the number of sides in the polygon. So here they're telling you that this is the interior angle. How do we figure out the sides? What formula were we using to figure out the one interior angle? The n minus 2 times 180, right? But also divide it by n, and all of this gave me 135. What do y'all want to do? Remember, the only way to undo something is to undo their process. So we subtracted, we multiplied, then we divided. If I'm undoing this, I'm trying to undo the last step I initially did. So what would I have to do first? Multiply. Well, what did I divide by? N. So I'm going to multiply by n. That's going to cancel out the n in the denominator. You still have the 1 up on top. So n minus 2 times 180 is now equal to 135n. What else can we do here? What now? Say it one more time. Can't plug it into the n yet. Can I divide by the 180? I can. I don't know if 135 and 180 will give me a nice whole number, though. What else could we do? What else can we do on the left side? Algebraically, what else can we do on the left side? Not add the 2 yet. It's going to be distribute, because we can't add the n yet. This is one whole number. This is representing a number, and I just can't subtract the 2 till I get rid of the 180. So I'm going to multiply both sides by 180. That would be 100. I can't see that. 180n minus 360 equals 135n. Now I can move over my n. So what n am I going to move over?
180.
The 180. So I'm going to subtract the 180. And I'm left with negative 360 equals a negative 45n. So what would be our last step? Divide. What do we get for the n value? 8. And it just wanted to know the number of sides, so we don't have to classify it as the octagon. Okay, I'm going to show you another way to do that one, though. You do have the process. I'm going to show you a different way. All right, so let's go to the next page. All right, so on this one here, it says the measure of an interior angle of a regular polygon is 144. Oh, you know what? I'm not going to have you guys do that one yet. Let's come down to this one. It says examine the polygons below in which an exterior angle has been measured at each vertex. What is the sum of the exterior angles in each polygon? So let's see. Adriella, can you add these for me? And then Jaden, can you add these for me? And then Brandon, if you can add these for me. All of these angles. Do we agree that they don't have the same amount of sides? Right? They have different amount of sides? Okay. Adriella, what did you get? Good. Jaden? And Brandon? They all came out to 360. Are these angles inside or outside though? They're outside. These are called exterior angles. The good thing about exterior angles is that it's pretty easy to memorize because they all equal the same thing. So all of these angles, when they're outside, they should all equal 360. I used to have a presentation or a demonstration where it kind of shows you why, but that program doesn't even exist anymore. But what it does is it pulled this vertex, this one, and well, all 5 of them, into the center. And what it did is it made a circle. Well, how many degrees are in a circle? 360. So that's why the exterior angles have to be 360. So exterior angles, kids don't usually struggle with this one because this one, again, they all equal the same thing. So we'll just do one of them. Let's do 105 plus 40 plus 105 plus x equals 360. Okay. What do we get with the whole numbers? 250, bless you. Plus x equals 360. So what's our value of x here? 110. All right, let's look at B though. B says, find the measure of each exterior angle of a regular dodecagon. Dodecagon has how many sides? 12, good, 12. And exterior angles have to add up to 360, good. Think about this. If we had 3 sides on a triangle and we had 3 angles inside, how many angles do you think we have outside? 3. It's always going to be the same number. So if you have 12 angles inside, we have how many on the outside? 12, good. So what's 360 divided by 12 exterior angles? I'm just writing that out so you know why we have the 12 there. 30 degrees, good. So I'm not going to have you do the practice because I'd rather spend time on this explanation. It says, is there a relationship, don't know why there's the asterisk there, but is there a relationship between one interior and and its adjacent exterior angle? Do you think there is a relationship between an exterior angle and the adjacent interior angle? 180. These are all supplementary angles. They're all linear pairs. So these two are a linear pair. Every exterior and every interior should equal 180. We'll draw one down here. That way you're not messing up that picture. So just draw, you can draw a triangle. And all you're going to do is you're going to take one side and you're going to follow it out. Pick up where that side is. And you're going to follow it out. Pick that side and follow it out. And then just make yourself a little diagram that every interior and every exterior should equal 180. That's going to be helpful with some problems. Because there'll be some where they give you the exterior, but you have to figure out the interior to figure out what your answer is. Okay, so very important. Don't forget linear pairs there. All right, and I think that's the last one on this page, right? So we got one left, I think. Okay, so I'm going to go back to that. Remember that one we just did where we had to distribute and then move over the end? That one was kind of long. There's another way to get around it. So same question. It says the measure of an interior angle of a regular polygon is 135. Find the number of sides in the polygon. So think about the exterior angles. All exterior angles have to add up to what? 360. Good. What did we just say about the relationship of an interior and an exterior? They have to equal 180. So if the interior is 135, if the interior is 135 degrees, what would the exterior angle be then? How much? 45. Because again, these two have to add up to, no, these two have to add up to 180, right? One interior, one exterior have to add up to 180. And because it's regular, we know that all the interior angles are the same, all the exterior angles are the same. So then if I want to figure out the number of sides of a shape, what could I do? What did we say all the exterior angles add up to? 360. So you can take 360 divided by 45. What's 360 divided by 45? I heard, sorry, I was writing this out. It's 8, and isn't that what we got on the last one? You can also do it this way. Which way you want to do it. I feel like this is less steps. You don't have to remember the distribution and the subtraction looking like it's reversed, but it's whatever method y'all want to use.